The examples on the previous slide are just a handful of things that immediately come to mind when you ask the question, what does an ADS need to take care of that has to do with failures of the equipment other than the ADS itself? A more general way of approaching this is asking how controllability is accomplished when you have no human driver to deal with controlling potential faults. Controllability is a concept in ISO 26262, which is used as one of the factors to determine the automotive safety integrity level, ASIL, of a particular safety requirement. ASILs run from QM to ASIL D as in Delta, but a lot of the lower ASILs are only accessible if you have high controllability. In other words, the own vehicle driver or some other actor in the situation is able to prevent a bad outcome even though some sort of fault has activated. With an ADS, there are two ways to go, and every safety requirement will have to determine which of these two ways or some combination it uses. If you want to claim that an existing vehicle component is only rated at ASIL A or ASIL B because it has good controllability for failures in a normal car, then the ADS will have to exhibit the same controllability to avoid having to change the ASIL rating. For example, if there's a component that when it fails causes something potentially deadly, but a normal human driver would be expected to very easily mitigate the risk, then that component could justifiably have a low ASIL in a human-driven car. But retaining that ASIL imposes a requirement that the ADS has to also know how to control the fault if it should occur. Alternately, if the ADS doesn't know how to control the faults in all the many components that could result in a bad outcome, then those components have to have their ASIL upgraded based on a C3 uncontrollable rating. Upgrading the ASIL requirements for components across the car could mean significant redesign, significant expense. This means when you're converting to an ADS, you need to revisit every single component on the vehicle that has some connection to safety and either upgrade the ASIL so the ADS does not need to worry about it, or you need to understand what it means to mitigate a failure of that component. In other words, what controllability exactly was taken credit for in the safety analysis, and teach the ADS how to exhibit that same level of controllability. In other words, if you remove the human from the vehicle, you're removing a very powerful general-purpose fault mitigator, and the ADS has to either replace it or you need to upgrade the integrity of the components so that the failures fall in line with ISO 26262 requirements. There's an additional challenge if you're adding an ADS to an off-the-shelf vehicle that you may not know all the controllability assumptions that took place when the vehicle was designed. You may not have a set of ADS requirements for controllability because the designers just assumed humans generally do the right thing. But now you need to understand how to teach your ADS to do the same thing when you may not even be sure what those requirements are.